Today's lesson is standard equation of a parabola with the vertex at the origin. A parabola is a set of all points P in a plane that are the same distance from a given line called directrix and a fixed point called focus that is not on the line. Let us look at this illustration. In this illustration, this is a parabola. This point is the vertex of the parabola. This point is the focus of the parabola. This yellow line is the directrix. Point A is a point on the directrix. Point P is a point on the parabola. It represents every point on the parabola. According to the definition of a parabola, every point on the parabola is equidistant from the focus and the directrix. So, PF is equal to PA. That is, the distance of P from F is equal to the distance of P from the directrix. Standard equation of a parabola with the vertex at the origin. The focus is on the y-axis. Let us look at this illustration. This is the y-axis. This is the x-axis. This is a parabola with the vertex at the origin. The coordinates of the vertex are 0, 0. This is the focus of the parabola. It has coordinates 0, p. This is the directrix, the yellow line. The equation of the directrix is y is equal to negative p. Point A is a point on the directrix. It has the coordinates x, negative p. The y-axis is the axis of symmetry. The equation of the axis of symmetry is x is equal to 0. Point P is a point on the parabola. It has coordinates x, y. It represents every point on the parabola. According to the definition of a parabola, every point on the parabola is equidistant from the focus and the directrix. That is, the distance of P from F is equal to the distance of P from point A or from the directrix. Based on the definition, PF is equal to PA. Using the distance formula, we have the square root of the quantity x minus 0 squared plus the quantity y minus the p squared is equal to the square root of the quantity x minus x squared plus the quantity y plus p squared. Y minus the negative p becomes y plus the p. Squaring both sides, we have x squared plus the quantity y minus p squared is equal to the quantity y plus p squared. This becomes the 0. Squaring y minus the p and y plus p, we have x squared plus the y squared minus 2py plus the p squared is equal to y squared plus 2py plus p squared. Solving for x squared, we have x squared is equal to y squared minus the y squared plus 2py plus 2py plus the p squared minus p squared. Simplifying, we have x squared is equal to 4 py. This is a standard equation of a parabola with the vertex at the origin and the focus is on the y-axis. Standard equation of a parabola with the vertex at the origin, the focus is on the x-axis. Let us look at this illustration. This is the y-axis. This is the x-axis. This is a parabola with the vertex at the origin. The coordinates of the vertex are 0, 0. This is the focus of the parabola. It has coordinates the P, 0. This yellow line is the directric. The equation of the directric is x is equal to negative P. Point A is a point on the directric. It has coordinates the negative P, y. The x-axis is the axis of symmetry. The equation of the axis of symmetry is the y is equal to 0. Point P with the coordinates x, y is a point on the parabola. It represents every point on the parabola. According to the definition of parabola, every point on the parabola is equidistant from the focus and the directric. That is, the distance of P from the directric is equal to the distance of P from the focus or from F. So we have PF is equal to PA. PF, the distance of P from F, is equal to the distance of P from A. Using the distance formula, the square root of the quantity x minus p squared plus the quantity y minus 0 squared is equal to the square root of x minus p, that becomes x plus p, and then squared plus the quantity y minus y squared. Squaring both sides, we have the quantity x minus p squared plus the y squared is equal to the quantity x plus the p squared. This becomes 0. Squaring x minus the p and x plus p, we have x squared minus 2px plus the p squared plus y squared is equal to x squared plus 2px plus the p squared. Solving for y squared, we have y squared is equal to x squared minus x squared plus 2px plus 2px plus p squared minus p squared. Simplifying, we have y squared is equal to 4px. This is a standard equation of a parabola with the vertex at the origin. The focus is on the x-axis. X squared is equal to 4py and y squared is equal to 4px are standard equations of a parabola. When the standard equation of a parabola is x squared is equal to 4py, the coordinates of the vertex are 0, 0. That means the vertex is at the point of origin. The coordinates of the focus are 0, p. It opens upward if p is greater than 0. It opens downward if p is less than 0. The directric is y is equal to negative p, and the axis of symmetry is x is equal to 0. If the standard equation of the parabola is y squared is equal to 4px, The coordinates of the vertex are 0, 0. That means the vertex is at the point of origin. The coordinates of the focus are P0. It opens to the right if P is greater than 0. It opens to the left if P is less than 0. The equation of the directric is X is equal to negative P, and the axis of symmetry is the Y is equal to 0. Example number 1. Find the equation of the parabola with vertex at the origin and focus at point 0, 2. Let us say this is the y-axis and this is the x-axis. This is the point of origin. It is the vertex of the parabola. It has coordinates 0, 0. This is the focus of the parabola with coordinates 0, 2. This is in the form of 0p. P is equal to 2 and P is greater than 0. If the focus is on the y-axis and P is greater than 0, then the parabola opens upward, and its equation is in the form of x squared is equal to 4py, where p is greater than 0. Replacing p by 2, because p is equal to 2. So we have x squared is equal to 4 times 2 times y. Simplifying, we have x squared is equal to 8y. This is the equation of the parabola with vertex at the origin and focus at point 0, 2. Example number 2. Find the equation of the parabola with the vertex at the origin and focus at point negative 3, 0. Let us say this is the y-axis and this is the x-axis. This is the origin. It is the vertex of the parabola. The coordinates are 0, 0. This is the focus of the parabola with the coordinates negative 3, 0. This is in the form of P0. P is equal to negative 3 and P is less than 0. If the focus of the parabola is on the x-axis and P is less than 0, then the parabola opens to the left, and it has an equation in the form of y squared is equal to 4px, where p is less than 0. Replacing p by negative 3, because p is equal to negative 3, we have y squared is equal to 4 times negative 3 times x. Simplifying, we have y squared is equal to negative 12x. This is the equation of the parabola with the vertex at the origin and focus at point negative 3, 0. Example number 3. Find the equation of the parabola with the vertex at the origin and directric x is equal to 2.5. Let us say this is the y-axis, and this is the x-axis. This is the point of origin. It is the vertex of the parabola. It has coordinates 0, 0. This is the directric. The equation of the directric is x is equal to 2.5. If the directric is parallel to the y-axis, then the equation of the directric is x is equal to negative p. X is equal to 2.5, so we replace the x by 2.5. So we have 2.5 is equal to negative p. Dividing both sides by negative 1, we have p is equal to negative 2.5. This is the x coordinate of the focus. So the focus now is negative 2.50. This is in the form of P0. P is equal to negative 2.5 and P is less than 0. If the focus of the parabola is on the x-axis and P is less than 0, then the parabola opens to the left, and it has an equation in the form of y squared is equal to 4px, where p is less than 0. Replacing p by negative 2.5, because p is equal to negative 2.5, we have y squared is equal to 4 times the negative 2.5 times x. Simplifying, we have y squared is equal to negative 10x. This is the equation of the parabola with the vertex at the origin and directric x is equal to 2.5. Example number 4. Find the equation of the parabola with the vertex at the origin and directric x is equal to negative 7. Let us say this is the y-axis and this is the x-axis. This is the point of origin. It is the vertex of the parabola. It has coordinates 0, 0. This is the directric. According to the problem, the equation of the directric is the x is equal to negative 7. If the directric is parallel to the y-axis, its equation is x is equal to negative p. Replace x by negative 7 because x is equal to negative 7. We have negative 7 is equal to negative p. Dividing both sides by negative 1, we have p is equal to 7. This is the x-coordinate of the focus. So the coordinates of the focus now are 7, 0. This is in the form of P0. P is equal to 7 and P is greater than 0. If the focus of the parabola is on the x-axis and P is greater than 0, then the parabola opens to the right. And its equation is in the form of y squared is equal to 4px, where p is greater than 0. Replacing p by 7, we have y squared is equal to 4 times 7 times x. Simplifying, we have y squared is equal to 28x. This is the equation of the parabola with the vertex at the origin and directrix x is equal to -7.